Example 2, domain and range. Example 2, for the graph of y equals f of x, state in part A the domain of f of x. So here we have the graph, there it is, the function starts, the graph starts here at this point and stops here. So the domain is quite restricted here, and we can see it directly from this picture that the domain of the function f is just the interval of all values of x between -2 and this value here, which is the value of 0. So what I could write is this, -2 to 0. So this is the interval of all values that can be input into the machine representing the function f. So function f is represented here by this red machine. So anything that is from the interval from -2 to 0 can be fed into this machine, and what we get at the output is the set of all numbers which form the range of this function. And if you observe this graph here, you see that for -2 we get the smallest output, and it's 0 actually, and for 0, which is here we have the 0 value there, for 0 we get the largest output, which is 5. So the y values that appear here at the output, those values are from the interval from 0 to 5, and therefore this interval is the range. It's the range of the function f. So the range of the function f consists of all the values, of all real values between 0 and 5, including the endpoints of the interval. Okay, so that's part A and B. Okay, in part A we answered what the domain is, in part B we answered what the range of this function f is. Now part C and D address the inverse of f. Okay, so first let us try to construct it here in this graph. So what I add first is this feature here, this closed circle in this position and in that one. So this circle here represents the point with coordinates of -2 and 0, and that circle here represents a point with coordinates 0 and 5. As we already know, the inverse, well, this is the function f, the inverse of the function, let me use the blue color to represent it, contains all the points which are reflections of the points lying on the graph of f, and they are reflected in this green line. So instead of the point with coordinates of -2 and 0, we should get the point with coordinates 0 and -2, so this one. So you may remember that reflecting the point in this line amounts to interchanging its x and y coordinates. So instead of -2 and 0, what I get here is 0 and -2. Moreover, we can do the same here with the point of 0 and 5, which is this second endpoint. And this is reflected to the position of 5 and 0. So it's 3, 4, 5 and 0. So it gets reflected to this point. So it's 5 and 0. And therefore, this is true also for all those points lying in between, and therefore the graph of the function, of the inverse of this function, should be or should appear in between these 2 points. So I just connect them here and in this position there, and use perhaps the blue color and a thicker line a little bit. So well, it should be blue perhaps, or let's say this one, and it should be in this form. Okay, so let me denote it. So this is F inverse, the graph of F inverse. And now perhaps it's the right time to answer parts C and D. So in part C, we should state the domain of f of x, of the inverse of x. So look here at this graph. The inverse of x has the domain which is represented by all the x values uh, which belong to this graph. So we start at 0 and end here at 5. So we may say that the domain of the function f inverse is the interval from 0 to 5. So it's the interval of x values. Moreover, we see that the range of this function, which is represented by all the y values that appear on its graph, is range of the inverse of f, and it should be the interval starting here. So this point here is -2, and this should be its endpoint. It's 0, so it's from -2 to 0. Okay, so we see that there is a correspondence here. So the domain of the function f is the same as the range of the inverse of the function, and moreover, the range of function f is the same or identical with the domain of the inverse. This can be understood also using the image or the idea of representing functions with function machines. So imagine this would be the function machine representing the inverse function. So if the original function f had the numbers from the interval -2 to 0 at its input, and at the output appeared the numbers from 0 to 5. So the inverse function should reverse this process. So at the input should be exactly those numbers which are at the output of f. So here we should have x in the interval of 0 and 5. So this should be the domain of the inverse function. So the same set as this one, and at the output we should get the numbers which are identical to those which are at the input of the original function. So here I should have the numbers y in the interval of -2 and 0, and this answer should be in line with the previous answers obtained using the graph.